So I was playing Tamodachi.Life, living the dream, and I was thinking, gee, this game is great. How difficult would it be to make my own version? And over the course of a month, that is what I did. As you can see, the game is very bare bones, but I enjoyed making it, and it is a much better way to spend time than doom scrolling anyway, and I hope it inspires you to make your own projects. So here is our program. So every time you start the game, it'll try and load a save. If no save is found, it'll say failed to find save, starting new game. As of recording this, it is 10:24 AM, so it'll tell you the time. And because it wasn't able to find a save, this is the new game starting sequence. So we're going to create a guy. Same in Tamodachi Life. For each field, it has to be non-zero values within the range of -4 to 4. So how much do they move? Let's say 3. How much do they talk? Let's say 2. How much energy do they have? 1. So -1, -2, -3. Let's make them a male. Let's not make them a child. If they are a child, they can't have dating preferences. Let's say they like men, women, and non-binaries. Oh, we named them -3. That's funny. Let's say yes. So this is their summary, their content, their male. They like male, females, and non-binaries. They're kind of bored. Let's invite someone to the island. Let's say 1, 1, 1, 1, 1, and let's name them person. And let's make them female. Let's not make them a child. Let's say they like men, women, and non-binaries. So there is their summary. What is their favorite object? So now they're going to prompt us about our favorite object. Basketball. And then they have a conversation. Yo, person, what do you think about basketball? Yo, I love basketball. Okay, so now we're out of the intro sequence. We're into the main game. Let's buy some food. So we're going to press 2 to buy food. And we have pizza, jerky, peanuts. Let's buy some jerky. We have bought some jerky for $9.50. Our new balance is $9.50. Now every time we exit the main menu, they're going to ask us a question. So what is an object that I am really fond of? Let's say Game Boy. Oh, Game Boy, I could really do one of those. Okay, so now if we go back into the food menu and we do A to view more stock, because we have bought jerky before, we can buy it again for $9.50. And what is an object that we are really fond of? Let's say chocolate. Okay, and now we can do S to save the game. Saving successful. They're going to ask us a new favorite object. I'm going to say computer. Okay, now because we have saved the game, we can press X to exit. And we can do yes. And now, hopefully, if we run the game again, we have loaded our save. So now, if we view the Tamodachis, we can see we have -3 in person. Let's do person. We can give them some food. And we have some jerky that we can give them. 1, person is eating jerky, person thought it was alright. Person gained 500 XP, they are still level 0. And yeah, that's pretty much the game that I've coded so far. As you can see, it is very bare bones, but yeah, you can see we have some basic functionality, and yeah.
Currently, this game is written in C# in Visual Studio as a console application. Okay, let's start with the global class. This contains a bunch of static global variables and functions that are central to the game's logic. Personality names contains enums that contains the names for each personality. Then personalities are stored in a personality array, which contains personality name enum, an array of attribute ranges, and an array of phrases. An attribute range has a field array. Upon initialization, it must be of length 2, and the first value must be less than the second value. It contains a function that returns true if the value is greater than or equal to the first value, or less than or equal to the second value. Fields are just integers that upon initialization have to be greater than -5 and less than 5 and cannot be 0. Phrases contain a string and an array of system.time-onlys. Very similar rules occur for the array of system.time-onlys as attribute ranges. It must be of size 2, the first value must be less than the second one. As in the game, my game, the 5 attributes are energy, talking, seriousness, movement, quirkiness. There is a function in the personality class that will return true if each of those attributes matches the attribute ranges. And in my game, I only have 3 personalities: happy, sad, and content. The global class also contains a food names array, which is an enum containing the names of each food. It has a food dictionary, where the key is the enum and value is the string. This is used in the food name to string and string to food name functions. There is also a food array, which contains the actual array of all the foods in the game. The food class contains a food name representing the name of the food, a double representing the price, and a personality name representing the personality that would like this food. In general, I like to use enums representing the names of objects instead of the objects themselves to save on memory. And upon initialization, the price of a food can't be less than 0. eGender is an enum representing the names of each gender. Okay, those are the main global variables. The global class has a bunch of functions, but the main one I want to focus on is menu. This is a general purpose function that allows the user to select from an arbitrary amount of objects. If you didn't know, in C#, object is a base class. This means that object can be used for any class, basically. Now, this function is special because it takes 2 lambda functions. A lambda function is just an anonymous function that can be passed as a parameter to a function. The first lambda function takes 2 integers. One integer is the key press that the user will need to press to get an item. The second integer is the object's index in the array, and this function returns a string. So what this function does is it returns a string for each object, telling the user to press, for example, the 1 key to select object, and then the function will return that object in the name of that object using the toString function. The second lambda function takes 1 integer and it just gets the object out of the array, so it returns an object. Then an object is passed by reference to the function. This is how you get an object out of the function. And then there is also a string which defaults to empty. You would use the string if you want to have if you want the user to be able to fall back out of the function. And then, so those are all the parameters, and then this function returns an integer. It returns -1 for an incorrect input, 0 if the user falls back out of the function, which is where you would, if you want that to be a valid case, you would enter in the string. It returns 1 if the user successfully gets an object out of the menu, and it returns 2 if the user quits out of the menu and then no object is returned. The other main function is the main-loop function. This is where the central core of the game's logic sits. It will display a menu where the user can do an action, and then either one of 2 things will happen. Either 2 tamodachis will have a conversation, or a tamodachi will, like when the game was set up, it will ask the user about an object, and the user will enter that object, and that object will be saved in memory. Pretty much all that the main function does is just run this main loop function. Now, let's look at the program class, which contains the state of the game. It contains two system.date times, one for the current time, one for the previous time logged in, a list of tamodachi's, a list of food items representing the player's inventory, a list of food names representing every food bought in the game, another list of food names containing today's stock in the store. It contains a string representing the save file and a double representing the player's money.
So as I'm editing the video, I realized I forgot to add the program class also contains a list of strings representing objects. These are objects that the tamodachi's will talk about, for example, in the starting conversation in the game.
Tamodachi contains a string representing their name, a list of fields representing their personality, a personality representing their actual personality that is calculated, a gender representing their gender, a list of genders representing who they fancy, a list of food relationships representing their relationship with food, and a double representing their XP.
And another thing I forgot to add is that tamodachi's also contain a list of phrases.
The gender class contains an e-gender enum. I have this encapsulated inside a class so that I can override the toString in the case of, because the non-binary gender, for the enum you can't have spaces, but if you just print the enum of non-binary, it'll just be in camel case, which looks ugly. So in this class I have it set to, if the gender is non-binary, it writes it with a space, so that's why I have that class. The food relationship class contains a food and an integer. The integer represents how much the tamodachi likes that food. The like function takes a tamodachi and returns true if the two tamodachis will get along. The match function also takes a tamodachi and returns true if the two tamodachis could be in a relationship. The save function takes a string and returns a string of the tamodachi saying that message. The talk function takes a string in the form of a backup message and a time only representing the current time, and it will return a string of the tamodachi talking. The conversation function takes a tamodachi, a real-world object, in the form of a string, and in the indentation level. This refers to how much tabs are going to be appended to the start of this conversation, and then it will return a conversation of those two tamodachis talking. The eat function takes a food, an indentation level, and then it also takes an action, which is a function that just lambda function that basically doesn't return anything, and then it also takes a lambda function that will return a string and will take a string, and then the action also takes a string. These functions basically are placeholders for console.read line and console.write line. The reason why I don't use them in this class is because I only like to have these functions in the global class where the entry point is, so that way if someone wants to make a UI, they don't have to go hunting around for all these console.write lines. They're all just in one class and they're all easy to find. And this function will make the tamodachi eat a food, and then it will handle the case of them leveling up from eating the food. So that's why I need those lambda functions there. The food items class contains a food and the integer representing the amount. It contains functions to add and subtract from this amount. The main functions in the program class are save and load. They do exactly what they say. They save and load from the save file. By default, this save file will be generated when you first save the game in tamodachi/tamodachi/bin/debug/ I think it's .NET 10.0, and then it will just be wherever the exe is generated, so it'll be right next to there. It is in human readable format, which I will go into in the next section, which means if you are doing debugging, it is really easy to edit the save file and therefore change the state of the game without having to do it manually, either by hard coding values or by manually editing the game yourself. But it also means that if you are a cheater, it is really easy to, say for instance, give yourself $1 billion or unlock all the foods in the game or do stuff like that. So if you're into that kind of thing, it is really easy to cheat in this game. Let's start with an empty save file. At the start we have tamodachi's, and the tamodachi's are denoted by their name. Then we have a list of fields, their gender, their fancy, a list of phrases, their food relationships, and their XP. And then we have the rest of the game state. So we have all their objects, the player's money, all the foods that have been encountered, and all the foods that are stocked in today's shop if that has been generated. And then at the start of the text file, we also have the time that this save file was created. Okay, now we have a more populated save file. We have 3 tamodachis: happy, sad, and indifferent. We can see that the happy tamodachi has 2 phrases, each phrase at the start and end time. They fancy non-binaries and females. And we can see that we have encountered 3 foods: sushi, burger, and chicken. You can see we have in our inventory 101 sushis and 51 McChickens.
Now, in the case that someone would like to extend this project, I'm going to give examples of future work in ascending order of difficulty. Number 1 would be adding new foods. This would be extremely easy. You just have to update a few values. I am lazy, so there are only 18 foods currently in the game, but you could easily add more. Second order would be adding more personalities. This would be a little bit tricky because you'd have to do some balancing to find the right values, and it's a little bit more involved to add more personalities, but it's still pretty easy to do. Another thing you could do is add more actions for characters in the game. Like you could see in our playthrough, it got very repetitive. They were constantly asking us about new objects. This is pretty easy to do, but a little bit more involved than the other ones. And then probably the hardest thing to do would be to actually add a UI. This would require some overhauls of functions. I have tried my best to make the game as modular as possible, so I don't think it would be like an impossible task or anything, but it would definitely be a big challenge to do that. And of course, ultimately at the end of the day, this is just meant to serve as inspiration for projects that you can do by yourself in your free time. Just an example of what the kind of projects you can make if you decide to put your mind to creating something. Well, that is my version of Tamagotchi life. It is very bare bones, it has a lot missing, but I had a lot of fun creating it, and I hope it served as inspiration for you as the kind of projects that you can make.